Hello students, and welcome to today's Form 3 Core Maths lesson. Our topic for today is plane geometry 2. Plane geometry 2. Now, plane geometry 2 is also called circle theorem. Circle theorem. Now, why plane geometry 2? Because this is a Form 3 lesson. Basically, normally you expect that this topic should have been taught hopefully in Form 2. Now, I'm looking at plane geometry 2 because it's one of the areas that most time when you speak to students, most of them raise issues about the fact that they did not really grasp that concept. So I felt that we should really look at it. I should take time to break it down in a way that students can grasp. And then also, you also notice that in recent times, you find a lot of your WASI questions from these areas. WAEC pick a lot of questions from this particular topic. And so as we revise, we feel that we should be able to take this topic and really look at it in a much more relaxed manner and in a manner that you students can really take time to pick it up. So that is why we are looking at plane geometry 2. Now, what is going to be the lesson objectives? At the end of the day, what do we expect that you will take away? Two things basically. One is that we expect that you should be able to state the theorems or the properties. That you should be able to state the properties, the properties or the theorems. Basically, we'll be looking at about 8 or so of them, and we expect that you should be able to state them, or you should know them by heart, or you should be able to state them and know them for what they are. The second is that we expect that you should be able to apply the theorems to solve problems. So basically, these are the two. This is going to be our two basic learning objectives. Now, our previous relevant information. Now, before you can handle this particular topic very well, you should have gone through plane geometry 1. You know, plane geometry 1 basically looks at areas like angles on the straight line, sum of angles on a straight line, vertically opposite angles, the angle properties of a triangle, the angle properties of a quadrilateral, polygons, and all of that. So that is one area. And more importantly, you should be able to, that really is your, but even more importantly, one of the areas you should be able to know very well and be able to help you build on is you should be able to know the parts of your circle. Basically, be able to draw your circle and name the parts. That is a very important aspect of this topic. So I will pick it up from there, and then we'll look at the properties right away. So let me clean what I have on the board, and then we'll look at that. Oh, okay. And then the best. Right. So we expect that you should be able to draw your circle and name the parts. So for a start, we know that you have. Now, what we have here, from what you know, is what we call the circumference, and this is your center. Now, any line from the center to any part of the circumference is what you call your radius. And then again, any line from any part of the circumference through the center to the other any part of the circumference is what you call your diameter. Now, any part of the circumference which is not the complete circumference, for example, a distance from this end all that way to say this particular end will be what you will call your arc. Now, a line from any part of the circumference to the other part, another part of the circumference which is not passing through the center, will normally be your chord. So the area between your chord and your arc, for example, the area I have here, will normally be your segment. And then again, an area, the area between two, when you pick this radius and another radius, in plural form we say a radii. So the area between two radii, for example, this area will normally be what we call your sector. So basically, as you know, these are your parts of a circle, and this is very, very important for you to be able to handle plane geometry 2 very, very well. And even more importantly, you should also know that anytime, as we said, anytime you have a circle and you have a chord, it divides the whole circle into two segments. And the segment that is bigger, in this case, for example, this particular one, is what you will normally call your major segment. And then the smaller one will naturally be your minor segment. Now, then again, in terms of sectors, again, once you have a you have a circle and you have two radii and you create sectors. You have two sectors. Again, the bigger one is your major sector, and the smaller one is your minor sector. So this information is very important for your takeoff. So now, in looking at the properties of the theorem, these are some of the information you need to take off. I hope it's very clear to you. So from here, we are now going to jump straight into looking at the various properties one after the other, and then we'll look at how to apply them to solve questions. Okay, so once again, let me clean and then we can move on from here. I hope you're already familiar with these things, because these are things you learn from JHS, in fact even primary school through to SHS. So you should be very familiar with these things. I needed to lay this foundation so we can move on. So let's get into the various properties, what I call the angle properties of a circle. The angle properties of a circle. Now, so the properties or the theory. Now the first one we want to look at. Now the first property or the first theory we want to look at is this. It says the angle a chord subtends at the circumference. The angle a chord subtends at the circumference of a circle in the same segment are equal. The angles a chord subtends at the circumference of a circle in the same segment are equal. So what it means is this: if I have a circle with a center and I have a chord, now as I said earlier, once you have a chord, you actually divide the circle into two parts, or you divide it into two segments. So you have this major segment and then this minor segment. So for example, if I'm restricting myself to the major segment, I'm saying that if the ends of the chord, these ends, subtends an angle, for example, if now the technical word subtend actually in simple language is forms. So if the ends of this chord forms an angle at the circumference, it forms an angle here, let me call it say A, in that segment, and then you have the same chord, the same ends of this chord forming another angle again at the circumference in the same segment, but it could be more, but let me just use these two. The rule or the property says that these two angles are supposed to be equal. So in short, we will say that in this case A should be equal to B. So that is the property. That is the property. And so this is something you must know. As we say, you must know it by heart. You should always be able to come up with it, be able to see it in questions and apply them. So let me pick a simple example for now. We will later get into looking at typical example where we will have to combine sometimes 2, 3, or 4 of the properties to be able to solve a particular question. But for now, let me pick a simple example to explain what I have here. So for example, if you were given this circle and you were given this, you were given that chord, and you were given this very simple example. Let's say you have X here, and then you have, let's say, an angle at 35 degrees here, and you were asked to find X. If you were asked to find X from this property or from this theory, you should know by now that these two angles are formed by the ends of this one particular chord, and they are all in the same segment. The condition is that the two angles must be formed by the same chord, the ends of the same chord, and then also they should be in the same segment. So these are the two most important conditions. 1, they should be formed by the ends of the same chord, and then 2, they should be at the circumference and in the same. So straight away from the property, we can straight away say that X is simply 35 degrees. X is simply. So that is the first property we want to look at, and I hope it's very clear to all of us. Okay, so quickly let's look at the second one. Let me look at the second one. Now, you notice that in the first property, okay, let me put it here. You notice that in the first property, we said that the two angles were in the same segment. Now the issue is, what if we have a situation where you have the ends of the same chord and the angles are being formed at the circumference, but this time the angles are not in the same segment? What happens? For example, in that case, I'll have something of this nature. I'm going to have something so that I have the end, this chord forming, for example, an angle here. Let me call this A. And then the ends of this same chord is also forming another angle, but this time not in this segment, but let's say in the other segment, or what we call the opposite segment. Let's say B here. Now this time, these two angles are not equal. But unlike the first one, the rule or the property is that we expect that the sum of these two angles should be 180 degrees. So in short, we are going to have A plus B equal to 180 degrees. So let me state the property for you. The property says that the sum of the angles, a chord or an axis obtains at the circumference of opposite segments is 180 degrees. The sum. So when you sum them, when you add the two of them up, we expect that the total should be 180. So again, let me put up a very simple example for now, and then we can move on. So for example, if we had a circle of a center, and then we had a chord, and you had this angle which is say Y, and then you had this angle which is on the other side, let's say an angle of 102 degrees, and you were asked to find Y. You were asked to find Y. From that second property, we can straight away say that because the two angles are formed by the same chord, but this time the two angles are in the different segments, we'll simply say that Y plus 102 degrees will give us 180 degrees. So that from this simple equation, we can say that Y is equal to 180 degrees minus 102 degrees, so that you will have to subtract. So 180 degrees minus 102, that is straight away the 78. Yeah, that's 78. So that is our second property. That's our second property. Now quickly, let's look at let's look at the third property. The third property. Now the third property states that the opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. Supplementary means that they sum up to 180 degrees. So what are we saying here? We are saying that if we have a circle with a center, of course, and you have a quadrilateral. A quadrilateral is a four-sided plane figure. So if you have a four-sided plane figure fitted into that circle, any four-sided figure at all, fitted into that circle, we have what we call a cyclic quadrilateral. So obviously we are going to have four angles. So let's say angle A, B, C, and D. Now we are saying that if you happen to have something of this nature, then your rule or your property in this case is that the sum of the opposite angles is supplementary, or there's when you sum the opposite angles, you are expected to get 180 degrees. So in short, we are going to have these and these, A and C are opposite. So your A plus C should give you 180 degrees, and then your B plus C should also give you 180 degrees. So that is your third property. That's your third property. So if I want to look at a typical example, so that if I had a W here and let's say 54 degrees here, and you wanted to find what do you call it, your W, you know that you have a cyclic quadrilateral in this case, because you have a quadrilateral fitted into a circle. And so the rule is that the sum of the opposite angles should be 180. So straight away you have your W plus 54 being equal to 180 degrees. And so your W from that simple equation should be equal to 180 minus 54 degrees. So your W in this case will be, what is it? 126 degrees. So that will be your the diagram, right? So that is your, now remember, my diagram is not drawn to scale, because naturally if you look at it, this angle is not, it looks like it's not even more than 90, but let's understand it from that end. Right, so quickly we jump to number 4. Remember, we are running through the properties. Now for number 4, let's look at that. The 4th property I want to look at is that if you happen to have a circle with a center and then a chord, now the angle formed at the center by the ends of this chord now, if the ends of this same chord also forms another angle at the circumference, let's say the angle formed here is A and the angle here is B. The rule is that the angle at the center is supposed to be twice the angle at the circumference in the same segment. And so we expect that your A should be equal to 2 times B. Now, on the other hand, this is when you know the angle at the circumference and you want to find the angle at the center. So on the other hand, if you knew the angle at the center and you wanted to find the angle at the circumference, it's just a question of, because this time you want to find B, there's a question of dividing through by 2, and so it's also the same as B is equal to A over 2. So either your A is 2 times B, or B is whichever one you want to find. So quickly, I will want to look at 2 basic examples here, so that if you were given a question where you knew, for example, that the angle here is 38 degrees and you wanted to find the angle here, say P. Now from property 4, as we have just gone through, we have said that the angle formed by a chord at the center is twice the angle formed at the circumference of the circle in the same segment. And so from here we can see that our P straight away will be 2 times 38, which gives us 76 straight away. On the other hand, if we had something of this nature, and this time we rather know the angle here to be, let's say, 72 degrees, and we wanted to find the angle x, or the angle at the circumference. Again, we know that twice the angle at the circumference is supposed to be equal to the angle at the, supposed to be equal to twice the angle at the center. So that from this simple equation, our x will simply be 72 divided by 2, so that our x will simply be 2 goes here, 3, 12, 6, 36. Right, so that will be for property number 4. So quickly, let's look at property number 5. Let's look at property number 5. In property number 5, let me clean this one so that we can quickly look at them. Now, property number 5 is more or less an extension of property number 4. You notice that we said the angle formed at the center is supposed to be twice the angle at the circumference. So that if we had a circle of a center, and then this time these, for example, these two radius are placed such that the two of them are in line, so that more or less they form a diameter. So the two radius are placed such that more or less they form a diameter. Then the angle, of course, we know that the angle formed here will be 180 degrees. And so for us to get, so straight away, the angle here will naturally be 90 degrees. And so the property goes this way, that the angle, a diameter of a circle, subtends at the circumference of a circle. In fact, for this particular property, the angle formed in any of the segments, not just in one of them, but the angle could be in this segment, or it could even be in this segment. It is still 90 degrees. It will still be 90 degrees. So anytime a diameter forms an angle at the circumference, that angle is always 90 degrees. It doesn't matter where it is, in any of the, so you're always going to get your 90 degrees there. So that is the fifth property. I think this one you don't need any serious example, except that maybe let me pick another one here, so that if I had a diameter, and let's say this is 27 degrees, and I wanted to find probably the angle Q. Now, from the property we just looked at, it will mean that the angle here is 90. And this time, you will need another property we have learnt already, coming from plane geometry 1. That is, the sum of the interior angle of any triangle is 180 degrees. So if that is what it is, then it means that in this case, we are going to say that our Q plus 108, plus the 90 degrees plus the 27 degrees will give you 180. So that from that simple equation you have 90 plus that is 107 degrees is equal to 180. 117, sorry, 117. So that our Q is equal to 180 minus 117. So that in short we have what?
163.
163.
63.
Sorry, 63 rather. 60. Sorry. 63 degrees. So that will be an example of property number 5. Okay, let's try and at least finish the properties for today so that in our subsequent lessons we can take time to take typical examples, as I said, where you will be expected sometimes to combine as much as 2, 3, 4 or 5 of the properties to be able to solve a particular lesson. So let me quickly look at property number 6. Property number 6, which is stated as equal chords subtend equal angles at the circumference of the circle. Equal chords subtend the same angles at the circumference. So that if I have a circle of a center and I have a chord, I have, say, this chord, and I happen to have another chord, let's say this chord, and I'm saying that these two chords are equal. And you know, in mathematics, to indicate that these two chords are equal, it means that I'll have to put that there. Now, so we are saying that the angle this chord will subtend, or it will form at the circumference. In this case, let's say A, and the angle that this chord will also form at the circumference, let's say B, must be equal. Why? Because we are saying that the two chords are equal. So if the two chords are equal and they are all forming an angle at the circumference, then we expect that the two angles should be equal. So straight away, your A should be equal to B. I don't think we need any serious example here. So for the sake of time, let's run through property 7. In this case, will be property 6. So property 7 follows after property 6, more or less, which says that equal chords subtend equal angles at the center. So again, if I have a chord that is subtending an angle, say A, at the center, and I have another chord that is also subtending an angle at the center, let's say B. Now, if it is proven that these two chords are equal, then we can safely say that the two angles must also be equal. So once again, your A should be equal to your B in this case. Then I will look at one property which is very, very important and very crucial under this particular topic, and that is bringing in tangents. Bringing in a tangent. And this is how it goes. It says that the angle, let me draw it first and then I will use it to state. So let's say I have a circle with a center and then I have a tangent. A tangent is a line that touches a curve or a circle at a point. A straight line that touches a curve or a circle at a point. It's a tangent. So if I happen to have, let's say, a tangent here, a line, a straight line, please forgive me, a straight line that is touching this circle, let's say at that point, at this particular point. Now, if I happen to have a chord such that one of the ends of that chord is at that point. So for example, I happen to have this chord here. Now, the property states that the angle formed by this tangent, the angle formed by this tangent, let me pick it from this end. The angle formed between this tangent and the chord, in this case through this segment, in this case this angle, should be equal to the angle subtended at the circumference in the other, by that same chord in the other segment. Now remember, this angle was through this segment. Now, if the ends of this same chord subtends an angle at the circumference, but this time not in that segment but in the other segment, so that I have something of this nature, this chord is forming an angle here. Now the rule says that these two angles are supposed to be equal. So now let me state the property for you. It says that the angle formed by a tangent and a chord through one segment is supposed to be equal to the angle subtended at the circumference by that same chord in the other segment. So in this case, we have A is equal to B. A is equal to B. Very, very important property. Very, very important. And you are going to find a lot of questions around this particular property. You're going to find a lot of questions around this particular property. So please take note. So what it also means is that if this time the angle is coming from this end, if from this tangent, if it is coming from this end, then this angle C, right? Now remember, this time it's coming through this particular segment. So if this chord is forming an angle in this particular segment, remember in the other segment, let's say D, then we can also say that C should also be equal to D. And that is very, very important. Now, a few other properties which are not really major. Now, another property I want to quickly mention is the fact that the length of the two tangents from a point to a circle are equal. So that, okay, let me clean this one and take it from here. But we'll be taking time to look at a lot of examples around this one in our next lesson. But I'm calling it, what we are saying is, if I have a circle with a center, and then I have this time two tangents. So I have one tangent at this point. Of course, now this angle is supposed to be 90. Now, if I have another tangent, let's say on this other side, this is also supposed to be 90. we are saying that these two lengths, now if I have, let's say, A, B, C, and D, D being your center, then we are saying that the two lengths AB should be equal to BC. The length AB should be equal to the length BC. Okay. So, for the sake of time, we will round up our lesson here. But fortunately, I think we've been able to go through virtually all the properties we need for what we are supposed to do under this particular topic. And so in our next lesson, we will take time to look at, to take the various properties as I stated in my second learning objectives, and then look at how to apply them, sometimes combining more than one, say 2, 3, 4 of the properties to solve particular problems. So thank you very much for today, and see you next time.